example, to add these equations, we add the x terms, the y terms, and the constant terms to create a new equation. Since the y term in the first equation is 3y, and the y term in the second equation is negative 3y, the sum of these terms is 0, and the y term is eliminated from the resulting equation. This equation can now be solved for the remaining variable x. Dividing both sides by 3, we get x equals 18 over 3, or x equals 6. Now that we know the value of x, we can set the value of x in either equation to 6 and find the corresponding value of y. Either equation will give us the same answer. In this example, since the second equation is the simpler of the two, we will use it to find the value of y. Setting x to 6, we can now solve this equation for y by subtracting 6 from both sides, giving us the equation negative 3y equals 3 minus 6, or negative 3. Dividing both sides by negative 3, we see that y is equal to negative 3 over negative 3, or 1. So the values of x and y, which simultaneously solve both equations, are 6 and 1. Starting with this same system of equations, instead of eliminating the variable y, we could have eliminated x. Simply adding these equations will not eliminate the variable x, since the x terms don't cancel. However, we can rewrite the second equation to make the x terms cancel by multiplying both sides by negative 2. Distributing the negative 2 multiplier to the terms in parentheses, we get negative 2x minus negative 2 times 3y, which we can write more simply as plus 6y. This is equal to negative 2 times 3, or negative 6. The x terms in these equations will now cancel when the equations are added. This gives us 9y equals 9. And dividing both sides by 9, we get y equals 9 over 9, or y equals 1. The value of y in either equation can then be set to 1, and the equation solved for x. Since both equations appear equally difficult, we will arbitrarily choose the top equation. We can now solve this equation for x by subtracting 3 from both sides, giving us the equation 2x equals 15 minus 3, or 2x equals 12. Dividing both sides by 2, we see that x equals 12 over 2, or 6. So once again, we have found that the values of x and y which solve this system of equations are 6 and 1.